Welcome. In this video, I'm going to be talking about comparing indices. Comparing indices is a skill that we use to solve problems that involve indices. And it follows the rule that if I have a to the power x, it's equal to a to the power y, for which my a is not 0, and my x and y are any numbers, it would mean that at this point x is equal to y. That is because the bases of each indices are the same. So I'm equating two index numbers, two numbers that have indices and have different powers. Their powers are equal at that point. Let me use an example. For example, if we have the question that says find the value of x for which 2 to the power x is 64. Now, in this case, my aim is to establish the same base. Now, because both of these are to the base, because I have the base 2, I can write 64 to the base 2 so that I can equate the powers. So I have 2 to the power x equals to 2 to the power something for 64. Now what we need to use here is you can quickly do some prime factorization or use your calculator to find out what is 64 in the base 2. So in this case I would say 2, and then this would be a 32, and then that would be a 16, and then this would be an 8, and if I continue dividing by 2, this would be a 4, this would be a 2, and a 2. So this gives me 1, 2, 3, 4, 5, 6. 2 to the power 6 is 64. So I have that 2 to the power x equals to 2 to the power 6. Now, because I've achieved this status that they have the same bases, I only equate at the point where the bases are the same. It means that my x equals to 6. Let me use a different example this time with an expression. What if we are required to find the value of x for which 27 to the power 2x minus 1 equals to 1 over 9. Now you should be able to write 27 and 1 over 9 to the same base. Okay? Now I already know that they are to the base 3. So I'll have 27 is 3 to the power 3 to the power 2x minus 1 equals to 1 over 3 squared. From the laws of indices, if I have a number to the power 2 another power, I multiply the powers. So this is going to be 3 into 2x minus 1. And then if I have a denominator, a fraction, I have 3 to the power negative 2. So because the bases are the same, I've achieved the status of the bases being the same, I can equate the powers or equate the indices. So this would be 3 into 2x minus 1 equals to negative 2. Expand out the brackets. So this is 6x minus 3 is negative 2. So if I add 3 on both sides, or if I take the 3 over to this side, I have 6x equals to 3 minus 2. 6x equals to 1. And at this point, my x is going to be equal to 1 over 6. How did I solve that? You need to make sure the bases are the same. Let's use another example. 32 to the power 2x minus 1 equals to 1 over 8. Now, in this case, I should be able to notice that 32 can be written to the base 2. Likewise, 8. If you are not able to do that, I would recommend you go through prime factorization to get which number can I write to a certain base for me to have 32. So this would mean I know that 32, from what I was calculating over here, I know that 32 is 2 to the power 5. If I did it from over here, 1, 2, 3, 4, 5. So I'll basically do 32 is the same as 2 to the power 5, and 8 is the same as 2 to the power 3. So I have 2 to the power 5 to the power 2x minus 1 equals to 1 over 2 to the power 3. Multiply the powers, so I have 2 to the power 10x minus 5 equals to 2 to the power negative 3 from the laws of indices. So I'm going to equate the powers. 10x minus 5 equals to negative 3. If I take the negative 5 on the other side, I'll have 10x equals to 5 minus 3. So 10x equals to 2. Therefore, my x equals to 5. So how did I solve this again? You need to write your numbers to have the same base, because when comparing indices, I will use when the bases are the same, the index or the powers are equal.